Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at an example of a word problem using systems of linear equations in three unknowns. So when you're working with systems of linear equations, you might see the questions expressed the way that we've been doing them in the examples, or they might be in the form of a word problem. So you might have a word problem that has two unknowns, and if you have two unknowns, you need to come up with two equations. You might have three unknowns, and therefore you're going to need three equations. I'm going to demonstrate one such problem, and I've sort of picked one of the hardest, I think, from a textbook called Basic Technical Mathematics by Ellen J. Washington. And it's a good example of using a system of linear equations to find three unknown values. So it's going to look confusing. It's going to have a lot of information, but I'll just go through the strategy that I would use if I was going to solve this problem. So let's take a look at it. It says, by weight, one fertilizer is 20% potassium, 30% nitrogen, and 50% phosphorus. A second fertilizer has percents of 10% potassium, 20% nitrogen, and 70% phosphorus. A third fertilizer has percents of 0% potassium, 30% nitrogen, and 70% phosphorus. How much of each must be mixed to get a total of 200 kilograms of a fertilizer with 12% potassium, 25% nitrogen, and 63% phosphorus? Lots of information, and it's a very challenging question, and students really struggle with this. What I would do first is set it up in a diagram like I introduced in the video on mixture problems. So if I take that information out of the words and put it in a diagram, I just have a little diagram for each fertilizer, and in that diagram I say the percents of potassium, nitrogen, and phosphorus. So I do that for each fertilizer. And those three things have to add up to equal my final fertilizer. I know I'm going to have 200 kilograms, or that's what I want to have, with these percentages of those components. So I want to know how much of the first fertilizer, how much of the second fertilizer, and how much of the third fertilizer. I have three unknowns, the amount of each of those three fertilizers. So I'm going to call them A, B, and C. So A, B, and C. And you can write a statement that introduces let A equal the amount of first fertilizer in kilograms, and so on. I actually have enough information here to get four equations. I have three unknowns, so I need three equations. The easiest equation is that I know A plus B plus C has to add up to the total weight or mass. So that's my first equation. A plus B plus C is equal to 200. Now, when I talked about mixture word problems earlier, I said that in your equation, you can only deal with one of the substances of your mixture, one of the components of your mixture. So I have three components, so I can make three equations, but I already have one equation, so I only need two more. I'm going to look at potassium, and the reason I'm choosing potassium is because we have a 0%, and that always makes it an easier system to solve. So the second equation is going to be about the amount of potassium. We take 20%, if we know it has to be 20% potassium and we have A kilograms, we take 20% of A to get the amount of potassium in the first fertilizer. So 20% of A, the percentage times the amount. I do the same thing with the second fertilizer. It's 10% of B, so 0.1 times B, plus This has 0% potassium, so 0 times C has to equal the amount of potassium in our final mixture, which will be 12% of 200 kilograms. So 12% of 200. That's our second equation, and we're going to clean this up and make it a little nicer. My third equation, now I can make an equation about the amount of nitrogen or the amount of phosphorus. I'll choose nitrogen. So I know my first fertilizer is 30% nitrogen, so 30% of the amount of 30% of A. My second one is 20% of the amount, so 20% of B. Third fertilizer is 30% of C, should equal 25% of the final of 200. I do not need to make an equation about phosphorus because I now have 3 equations. That's all I want when I'm solving a system with 3 unknowns. I'm going to simplify these 3 equations and then I'll go ahead and solve them. Okay, I rewrote the equations and got rid of the diagrams just because of a lack of space. I also want to express this as a number. So if I took 12% of 200, that would be equal to 24. And if I took 25% of 200, that would equal 50. Just to confirm what these equations mean, the first equation means that the amount of the first fertilizer plus the amount of the second plus the amount of the third equals our total amount of fertilizer in our final fertilizer. Equation 2 represents the amount of potassium. So the amount of potassium in our first fertilizer will be 20% of A. The amount of potassium in our second fertilizer will be 10% of B. The amount of potassium in our third fertilizer is 0. And the amount of potassium in our final fertilizer is 24 kilograms. Similarly, with nitrogen, there is 0.3 times A nitrogen in our first fertilizer, 0.2 times B amount of nitrogen in our second fertilizer, and 0.3 C kilograms of nitrogen in our third fertilizer. We want to end up with 50 kilograms of nitrogen in our final fertilizer. Most people don't want to work with decimals, so I'm going to take this equation and just multiply everything by 10 to get 2A plus B plus 0 equals 240. I'm going to do the same thing with the third equation. Multiply by 10, and I will get 3A plus 2B plus 3C equals 500. So there's my 3 equations. I have a choice whether I want to solve this system algebraically or with determinants. I use both methods depending on what the question and the equations look like. In this case, I would probably do it algebraically because I already have one equation that just has 2 unknowns. There's no C there. So if I did it algebraically, I could use these 2 equations, add or subtract them together to eliminate the C, and then I'll end up with 2 equations and 2 unknowns. So that's going to be my strategy. I will eliminate the C by taking equation 1. I need a coefficient of 3, so I'm going to multiply equation 1 by 3 to get 3A plus 3B plus 3C equals 600. I'm going to subtract equation 3. And the reason I'm subtracting is that they have the same sign. They're both positive, so I need to subtract to eliminate. So 3A minus 3A, hey, I eliminate the A as well. Perfect. 3B minus 2B gives me B. 3C minus 3C is gone. 600 minus 500 is 100. So I actually very easily got rid of 2 variables. So B is 100. I can plug that into equation 2 to find A. So 2A plus B, which is 100, has to equal 240. Subtract 100 from both sides. Now divide both sides by 2. So A is equal to 70. And once I have two answers, or two solutions of my three variables, it's easy to find the third. So we go to equation number 1. A, which is 70, plus B, which is 100, plus C has to add up to 200. So if we subtract 170 from both sides, C will equal 30. Now that we have a solution for all three variables, let's do a check. So equation 1, we can visually, we know that 100 plus 70 plus 30 equals 200, so we know equation 1 works out. Equation 2, we can do that easily too. 2 times 70 is 140, plus 100 is 240. Equation 3, 3 times A, which is 210, plus 2 times B, which would be 200, plus 3 times C, which is 90. Does that equal 500? We add this up. Yes, it does. So we know that our solution is correct. And because this is a word problem, we need to express our solution in terms of a statement. So we would say, we need 70 kilograms of the first fertilizer, $100 kilograms of the second fertilizer, and 30 kilograms of the third fertilizer. And we're done. So like I said, this is probably one of the tougher word problems you'll see in terms of systems of linear equations and three unknowns. You may or may not be ready for this. This might not be something that you're expected to do at this point, but there's an example if you do encounter something similar to this, a strategy for solving that. This video concludes the series on systems of linear equations. So I'm going to be moving on to a new topic in my next video. Take care and just